Hi all, this is Pradeep Vibhuti, Assistant Professor, SDM College of Engineering and Technology, Dharwad. In this session we will see hashing in data structures. So we'll see introduction to hashing techniques, and in this session we'll see why hashing is required, what is ideal hashing, that is one-to-one mapping, and what is modulus hashing, and what are the drawbacks of ideal hashing, and we'll see the solution to the drawbacks of ideal hashing. So what is hashing technique? Hashing is a useful for searching. For searching we already know few techniques which are linear and binary search. Linear search take a constant time of order n, and binary search is bit faster than that, and it takes a constant time of log n, which is faster than linear search. So basically hashing is used for searching an element in an array. So here we have an example, that is we have taken some keys. There are for example 8, 3, 6, 10, 15, 18 and 4, which are the size is 6, and the length of array is also, the length of array is 7, sorry, the size is 7, so the length is 7, that is 0 to 6. And in linear it is, you can observe that it is not in order, that is it is not sorted, but in binary search it is sorted. So this is one drawback of binary search, is that the elements must be sorted. You can see that it is in ascending order, wherein in linear search it is not. Now what is hashing is, we have to, before searching an element we will have to first store it. So how we are storing the elements in an array is hashing technique, and based on how we store the elements, based on that we can search easily. So storing is basic necessary. So here one-on-one hashing, what we saw, which is ideal hashing, that 3, that is element 3 is stored in the indices 3, element 4 is stored in the indices 4, and so on. You can see here 6 is stored in 6, 8 is stored in 8, 10 is stored in 10, so that we can easily access the number which we want. Suppose if you want element 18, if you simply go to indices 18, we will get the element 18. This is very simple, but the drawback is, you can see, suppose you have only a size of for example 7 elements, and in that one of the number is 99, you need 99 spaces. So where loss of spaces is inevitable in this case. So loss of memory is happening, so we are using more memory to store less numbers. So we'll see the same case again here. Okay, so I have taken different keys now, 8, 3, 6, 10, 15, 9 and 4, and here the hashing function is h of x equal to x. So since the biggest number is 15, I have taken up to 15, and this is the drawback of one-on-one mapping. We'll see how the mapping is been done. So 8 is stored in 8, and 3 is stored in indices 3, 6 is stored in indices 6, 10 is stored in indices 10, 15 is stored in indices 15, 4 is stored in 4. You can observe one more drawback here is, the key spaces should not be repeated, or there should not be any duplicate keys. the elements we are calling it as keys. So I'll just complete it. 6 is stored here, 8 is stored here, 9, 4, 10, 11 is not there, we have 15. Okay, so this is the drawback of one-on-one, that is key spaces should not be repeated, there should not be any duplicate keys, and the spaces are wasted. If one of the key is 99, you will have to use 99 spaces. So that is the drawback of this. To overcome this, what we do is we go for modulus hash function. So what is modulus hash function is the function here is not h of x equal to x, which was in earliest case. It is h of x equal to x mod 10. So it is mod here, and you know what is mod? Mod means remainder. Now in that case 8 will be stored, so x is 8, 8 divided by 10 is, so the remainder is 8. So this will be stored, 8 will be stored in the location 8. 3 divided by 10, so it is like this. 3 is divided by 10, so it cannot be divided, so it is 10 zeros is 0, so the remainder is 3. So mod refers to the remainder, mod refers to the remainder. So 3 is stored in location 3, 6 is stored in location 6, 10 is stored in 10 mod 10, it is 0, it is stored in location 0, and 15 will be stored in 5 because 15 divided by 10 is 10 ones are 10 and remainder is 5, so it is stored in location 5, indices 5, and similarly 9 will be stored in 9, and 4 will be stored in location 4. So this is how, even though the highest element is 15, we are not using 15 spaces here, we are using only 10, that is 0 to 10. Why? Because our mod is 10. If mod is 15, we should have taken 0 to 15. So this is the logic behind the hash function, and I'll just complete or fill the elements here, that is 10 will be stored here, 8 will be stored here, 3. So but still there might be a problem here when we have an element to be stored as 25. I think you might have already got this doubt. What if we have another number which is units place is 25, so that is 5, so this will also need to be stored in 5 location. Then in that case there will be a collision. So collision. So to avoid this we will see the methods. We have open hashing and closed hashing. In open hashing we have chaining, in closed hashing we have open addressing, and inside open addressing we have again three techniques called linear probing, quadratic probing and double probing, and next we will see chaining.